Mr. Goldsmith has been published more than a dozen times in professional journals, conference reprints, and newsletters. Perhaps his biggest claim to fame is the development of impact statements for hurricanes, wind, and storm surge flooding hazards. These statements were used by the National Weather Service offices in New Orleans and Houston, Galveston to provide real-world scenarios of devastation prior to Hurricanes Katrina in 2005 and Ike in 2008. And, people should have paid attention. I mean, they weren't paying attention to these things, Even my niece was there with Ike, and they thought, oh, well, there's nothing, we're not going to do anything. And her sister sent her a ticket and got her on the last flight out to Minnesota, because she was going to stay there in, these cardboard box apartments that they had. Okay, the statement heard around the world on August 28, 2005, one day prior to Katrina's landfall, is displayed in the Museum in Washington. Barry lives in Brownsville with his wife, Michelle, and his children, Callie, Pablo, who are cats, and Caesar the dog. Okay.
We have grown children. So.
And I have some brochures here for the Environmental Studies minor program, as well as a couple of them for the EAC.
Let's see if this is working.
Yeah, just put it in. There's also some brochures for the Environmental Science major and minor.
Okay, it's working. See if it's working from here.
Yeah. Okay.
Okay. All right. Good afternoon, everybody. Can everybody hear me? If anybody can't, let me know. I'll jump by the mic. But because I've got a wireless on, so it could be a bunch of interference with the wireless and that mic on. So I'm also much better stepping out into the floor a little bit than standing behind a mic. If I have to, I will. But if I don't, it's better. I'm going to try to go. I'm going to stand back here, though, so I can read my slides, because I don't know every single one by heart, but I know them well enough. So let's get started here. I'm doing two things this afternoon. One is discussing the current drought, the impact of the drought that we've been having in the valley, and then take a look at how climate change not only affects the nation and the world, but may affect the valley as well as we move forward. So two separate but somewhat related topics, and hopefully there'll be some time for questions. I've got a lot of slides to get through, but I really want to open this up from questions from you, because this is a much more entertained audience and probably energized audience than I get in some venues. And I really want you to have a shot at me and have some good questions. So, and I'll try to answer as many as I can. If I don't know, I'll tell you I don't know. So I'm going to get started with something that's not totally related to climate change per se, but really wanted to discuss, before we get into drought, the factor of heat. And we all know it's hot down here in the valley. We average in the 90s for 4 months out of the year: June, July, August, September. Some years we have it in May and October as well. So it's hot, but it's also relatively humid here. And that's the reason why we can grow certain plants in this part of Texas that we can't grow just 200 miles west of here in Laredo, where it's closer to being desert. And if you go beyond the hill country out to West Texas, you are in the desert practically. And it's a whole different ballgame. And why is that so? We have evaporation. We have slow rates that are pretty typical here most of the time. Light wind, high humidity. We have some wind here, but we have high humidity quite often. Keeps the rate in the slow to moderate range, because strong wind and high humidity very common, especially in the eastern part of the valley. We get an evaporation rate that's moderate. And it's common this time of year. You're going to see the wind machine kick in February, March, April, May. And then by summer, it should diminish a bit. Now, over here in McAllen and Edinburgh, there's days when it won't be windy at all, and it'll be howling over there by Brownsville and Harlingen. We're not going to explain why today, not enough time, but if you want to know, we'll give that to you later. Then there's high evaporation rate, and that's the real key here when we're looking at the drought situation. When we have strong wind and low humidity, and it happens in the fall and spring, and if it happens more frequently in the fall and spring, it can lead to real big problems down here regarding drought. And that's where we were last year. That's where we were from October 2010 all the way into the fall of 2011. And we actually broke it down a little bit December through February. But we'll tell you a little bit of bad news coming up for this situation later on. But that's a real key there. If you can see on my little laser pointer, high evaporation rate. is what really causes our drought situation to blossom and explode. And that's kind of what we were seeing for the last year, minus the last couple of months. So what happens with evaporation rates that are high or even extreme? We get into drought situation. And then we have what's called a positive feedback. The ground is dry, it gets warm, there's more energy going into heating, not into evaporation, evapotranspiration, so it feeds off itself and you get more dry. You have a high sun angle. We're down here at 25.9 to 26.1 degrees north latitude. That's not that far away from the true tropics of the Tropic of Cancer. So therefore, we have issues with sun angle, which can dry things out more. The wind we know about the wind, whether it's from the north or the south, it tends to blow down in the valley. And if it's blowing dry, it's going to dry things out even more rapidly than they would just with the dry ground and the high sun angle alone. And of course, the positive feedback. It feeds into drying out more. You get drier ground. It goes into more heating. And you see what happened last September, October, what happened back in 2009 during the summer, where instead of being in the mid to upper 90s, which is pretty hot as it was in the hundreds every day over here. And pretty amazing stuff. So 2009, we broke all-time records in this part of the valley. McAllen, Edinburgh area was just searing heat. Highs were averaging 104 degrees in July and most of August, which is 6 to 7 degrees above what it should be every day. So if you thought it was really hot 2 summers ago, you weren't wrong. It was really hot. And this is a place that already is hot, but we're not Phoenix hot. Normally, we're kind of more like the Gulf Coast, whether it's here, whether it's Mobile, Alabama, whether it's Houston, Texas, Corpus Christi, it's all about the same, plus or minus 2 degrees. But 104 degrees, that's much more like Phoenix and Las Vegas, and it was dry too. So real big deal. And we had a big drought then too, not as bad as the one we just had, but the summer drought was pretty fierce in 2009, and thankfully we had some rain to follow that. 2011, it got worse because we had the driest water year, October 2010 to September 2011 ever across the state of Texas. That's going back 150, 170 years, and the valley was no exception to that. And we had the expected impacts, 5 to 10 billion with a B, $1 billion in agricultural loss. That's dry land crops, that's unirrigated crops, that's livestock loss. Over 2 million, I think 660,000 head of cattle were lost due to the drought last year. And of that, I think 2 million total had to be either sold early or they were thinned out. The herd was not doing well. There was a major loss in beef production due to the drought last year. When you're number one in drought in Texas, that's saying something because we're kind of a dry state for a lot of times. It was really dry. And of course, we remember the wildfire season, $5 billion in damage. I believe there were 5 million acres that were consumed by wildfire, including more than 50,000 in the valley, which was the biggest number in a long, long time. So drought is a big deal. Well, Texas is one of those states that they have an old saying about, and it's not really so mythological. It actually has some truth to it. They say Texas is a state of perpetual drought broken by the occasional flood. And here we go. This was 2010. This was the water year starting in October 2009 all the way to September 30, 2010. And check it out. Number one. These number ones in purple, that actually shouldn't be purple, but the point is, number one is the all-time wettest water year, 2009-2010. And boy, that's a good thing, because if we didn't have that, imagine what we would have had to deal with last year, because just a year later, we got a bunch of purple number ones again on the other side. So we literally have gone from a very wet year in 2009-2010, with some cases being number one all time, to, in many cases here, the driest all time, with some of the numbers showing up below 5 inches just west of here. You can see the Center Valley, Edinburgh, McAllen, 7 inches, 4 to 5 inches out in La Jolla. Those are Phoenix, Tucson, not quite Death Valley numbers, but man, it got real dry. If you remember, it was dusty out to the west of here. It was almost like being in the desert. The grass just withered and faded, and the ground turned to dust. And that was not good. We got some relief. We'll talk about the relief that we had, thankfully, for a little while this winter, but that's not going to stay that way, we believe. Another thing that made the drought get worse was this ice storm. Now, you're probably wondering, why am I showing an ice storm picture? Well, it's kind of an interesting event. I mean, they don't come very often here. Every 20, 25 years you might get one. This one was really bad compared to even the earlier ones. Maybe going back to the 1930s in the Central Valley when you had one like this. So a long time ago. But unfortunately, when you combine frozen frozen plants such as grasses, things like cotton, dryland crops, sorghum, soy, what have you, and you add a drought on top of that, you've now compromised the ability of those plants to grow better during the spring when they've been frozen and kind of made into crispy type of feel to them. Add dry air to that, and it just exacerbates the process. So that's why I'm showing this. It had major impacts, making things worse than they might have been had it been not so cold last February, about a year ago from today. So ice and cold and freezes, they can have an impact on the crops as well when you combine that to drought. So here's an outlook, or is that a drought look coming up? Yeah, we've actually done pretty good this February so far. Knock wood for that. That's saving us a little bit, buying us a little bit of time, but not much time. You can see here the colors of the temperature. This number here, 50%, we're about 45 to 50%. What that means is that there's three categories: below average, average, and above average. And if you're pushing near 50% being above the average, it's kind of like the presidential campaign. You can win a primary with 40% of the vote if everybody else gets 20% of the vote, right? Same deal here. If you get 50% of the probability for above, those other ones, average and below, are about 25, 20, 24%, whatever each, which means there's a pretty good likelihood that you're going to see above average temperatures for the next 3 months coming up. We're also looking that it's going to be dry. Now, they've nudged an area of equal chances down into Texas. And the reason for that is because we've had some rain in January up north, in the north part of the state, and a lot in February. So they're kind of saying, uh-oh, we might not be so droughty after all, but we're going to hedge our bets and still go equal chances rather than above normal. For the valley, unfortunately, we're on this stripe here of 33 to 40 to 45% chances, again, of being dry. So, yeah, we'll talk about that break we just had, but don't get used to it. It looks like we're going to be heading back into a dry pattern. And as we talked about earlier with that heat and the fact that we have the higher sun angle, all that green you see out there today, it's going to last a little while. By mid-March, mid-April, it may be gone like that because that high sun angle, increasing wind, and drying air is going to flash dry it. And if we don't get rain by the time we get to June, it may look pretty bad out there, similar to last year. And unfortunately, we'll have more growth of the grasses, which can lead to fire weather danger, because the more grass you have, the more it can burn. So that's an issue we didn't think we'd have this year. We didn't have as much last year. We still have 50,000 acres burn. But this year we got higher grass again. So we may be back into a situation we have to worry about. So let's switch over to the ENSO, El Niño Southern Oscillation. A lot of people don't quite understand what this is and how it relates to things. I'll try to explain it in a few slides here. On the top, we have a El Niño situation, 2009-2010 winter. And the bottom, we're in the current situation of La Niña. And you notice that we have red colors here and we have blue colors here. The concern area is that highlighted, shaded, or outlined area in the red here and in the purpley color down here. What El Niño, La Niña simply means is that in an El Niño, we call it the warm phase. The warm phase means the eastern Pacific tropical waters get well above what they should be, and that's in this area of red. It's not just at the coastline of South America, but it's all the way out to near the date line. Okay? So it's a pretty good swath of waters that get pretty warm. It's known as the warm phase of the warming and cooling cycle. After all, it's an oscillation, the big O there. So oscillations, as you know, mean up and down. When we're in the warm phase, what happens is the fishing off of Peru changes quite a bit. And what the fishermen noticed back in the day was that the fish weren't running the way they should around Christmas. And we all know Christmas is about the time the Christ child is born, El Niño. So that's where the term came from the Peruvian, Ecuadorian fishermen back in the day saying, this is really weird. The waters are too warm. The fish aren't running right. We're not getting the population of fish we need to feed our people. And on top of that, we're getting all these floods because all this warm air is creating more moisture. It's running right into the coastline, and that's a problem for our community. So they called this term El Niño for this warming of the water. La Niña just means the reverse. That's the only reason we have a La Niña. It's not about the girl child. It's just saying if we got to have an El Niño because it's the Christ child, then we're going to just flip it and call it La Niña just to make it easy to understand and remember. And there we have it this winter and last winter. And La Niña means the cooling of these waters in the eastern tropical Pacific. So keep that in mind. Cooler waters, warmer waters. And when we go forward here, we're going to talk about how that impacts weather, not only across that area of the world, but across our part of the world as well. And here's how. This is the map that shows the January to March weather anomalies or patterns during an El Niño on top and a La Niña below. What happens in an El Niño is we get a very pronounced tropical to subtropical jet stream. This is energy in the atmosphere produced by those warm waters, which create warm, humid air over top of them, which likes to rise in the cooler atmosphere and create thunderstorms. And those thunderstorms cluster together and disturb the atmosphere in a large way. And they create additional wind shear, which is in the large scale and provides the impetus for a jet stream. Jet stream is basically made up of wind shear areas of higher versus lower wind speeds. Imagine going into a fast jet than out of a fast jet, like a car running through an accelerator. That's what these are. And they're caused by this differential heating and latent heating provided by thunderstorms. Voila, you have more wind shear. And if you have a lot of that, you can create its own little jet stream down here, which provides a lot of juice to the depth of the atmosphere. And it can produce a lot of rain down in the southern part of the U.S., the northern part of Mexico, from California all the way to Florida. And that's what typically happens. Wetter than average. It ends up being cooler, not because of the fact that the air masses are cooler, but when you have a lot of clouds and a lot of rain, you don't get the sun through it, and it cools down the atmosphere enough to keep temperatures average to below average. So that's your El Niño. Here is your La Niña. Your La Niña, you have a big blocking high pressure ridge, and the blocking high pressure can stretch from Alaska all the way down to the southwest U.S. and Mexico from time to time. There's a variable Pacific jet stream. It's not necessarily truly tropical. It may raise up, it may come down, it may raise up again, but the tendency is for it to bring the moisture into the Pacific Northwest, so places like Seattle and Portland, Oregon will get hit, but it dries it out when it comes into the Great Plains, and it really dries out when it comes to the south. So from California to Florida, it tends to be dry. Dry means more sunshine with a high sun angle. Remember, we're 25.9 to 26.1 degrees north, means we're going to get more warmth, and that's pretty typical of a La Niña. So you're probably going to ask, what happened this year? We got rain during this season. We'll try to explain that in a few slides. But anyhow, the difference in the cooling of the Pacific Ocean means fewer thunderstorms, if any, means less disturbed energy in the atmosphere, no latent heat, means less wind shear, which means tropical jet stream, don't have it. See you later, it doesn't exist. We still have jet streams, all right, but we have this variable thing. And without that deep tropical moisture, latent heating to produce precipitation, we go dry during a La Niña for the most part and for most of the season. And sure enough, here's your map. Here's your proof. 2009, 2010 winter, there was your average rainfall, anywhere from 4 to 8 inches above average for December through February. And for 2011, so far, December through February, last year, we were well below the average, not only on the coast but out west. There was a stripe of rain that actually fell nicely in mid-January from an independent event. But even considering the stripe of rain, we were 50 to 80% below or of the average. So we never even reached 100%, even with that good rain we had right around Highway 77, Brownsville to the King Ranch. That wasn't enough to put us above. But out west, as we know, here in Edinburgh, out through La Jolla, through Starr County, bone dry. Just didn't rain at all last year. Again, tropical jet stream doesn't exist. You can't get the moisture, you can't get the rain, and there's your difference in 1 year. So the science does matter. This stuff does make sense. In the longer term of El Nino, La Nina, where are we headed this year? Well, there's some good news, maybe. We're not sure how this will play out. But the forecast trend is to move from the La Nina that we've been in, which is about here in November, and by December, January, we were right about there, starting to rise out of it, but still in La Nina in the purple here. The forecast shows that we're going towards neutral as early as April, May timeframe, and the latest forecast, this is the latest, but the latest is the same. Hasn't changed any. There's even a possibility we could go to an El Nino when we get into the late summer, early fall. That might not be good because El Ninos in summer continue the wind shear, and hurricanes don't like wind shear. We need the water. So it kind of flips on a dime in the summer where we need to have the La Nina neutral. And so hopefully we kind of stay in that neutral zone to keep the wind shear down and get us some rain. I'm not saying we need the hurricane, but we need the really good tropical water to really knock this drought out once and for all. And there's some uncertainty as whether that'll happen. Because after all, you really can't forecast an event until you get it on the map. So there's more to it than El Nino, La Nina. And the reason I'm showing this chart is because you're going to say to me, well, Barry, you're an idiot because it's rained just December through February. Texas is above average overall. The valley was above average in December, above average in February. We didn't get much rain in January, but if you add it all together, we're going to come up slightly above average for the winter. And you're telling me it's bone dry. How can that be? Well, you can't answer everything in the atmosphere by this long-term El Nino, La Nina. That's why when you listen to the people on the national news, they don't understand enough. They say it's got to be dry because of La Nina, it's got to be wet because of El Nino, and then they start asking questions, well, why is it wet? Well, there's more to it. And here's something called the Arctic Oscillation. Now, the Arctic Oscillation is not as long-term as El Nino, La Nina, which can last a year and a half, as we're seeing this time around. These oscillations can go for months at a time, for weeks at a time, maybe for parts of a year. But they're not going to go for a whole year or two. That's why it's called an oscillation. It's on a smaller scale. It's basically differences in pressures between Greenland, Iceland, and northern Canada and these areas up here. That's all it is. El Nino is a difference in pressure between the eastern Pacific and Darwin, Australia. Look at those differences, you get positive and negative, and that's where the water temperatures come in, lowering pressure in the eastern Pacific versus Darwin. And with its cooler temperatures, it rises the pressure versus Darwin. So they're all related. Cooler temperatures mean higher pressure over top, et cetera, et cetera. But anyway, this pattern here of oscillation shows you that when you're in a negative phase, you have cold air that can drain into the eastern US and eastern Canada, and also into northern Europe. And you can get some pretty big snow events in northern Europe. I didn't say Central Europe, I said northern Europe. You've probably heard the stories about Europe this year. Kind of interesting how it's playing out. We'll tell you why. There's the cold air in the East Coast. East Coast snow, has there been much? Anybody think there's been a lot of snow in New York and Boston? Virtually zero. They've had some hits or misses, but mostly misses. In fact, DC, I think New York was at 7 inches last check, which is way below where they should be by late February, and winter's getting near the end. So we didn't have that. We had that last year. We had that 2 years ago. And we think that this pattern that was so persistent last year may have helped get our freeze going. But this year, no, we've been sitting on this, and we'll explain in a minute how that looks. So the cold air can drain into the extreme northeastern Canada near Greenland, but not the US. It really doesn't get down the East Coast. It helps to reduce the cold air. We've seen that. You combine that with a La Nina, you're guaranteed to have a light precipitation and low snowpack. And we'll show you a picture of that in a moment. But notice the storm track into Europe. Look at this. It says warm and wet here across northern Europe, but there could be little things going on here. Once in a while, getting the colder stratosphere to sneak down, the storm track's down south. And we saw what happened in Prague. We saw what happened in Italy. We see what's happened in England. There's been snow, and a lot of it in places that normally don't see it. But Siberia up in here has actually been warm. It's been one of the warmest years in a long time in Siberia. But it's been much colder to the south. Again, the storm track probably allowing more cloud cover. There's been some sneaky cold air, just cold enough to make it snow. Now, Prague gets pretty chilly. I mean, Prague does get into the teens and 20s most times. They go below zero. One time you can have a hit of Arctic air and boom, get cold in Prague. So we still think this is a main reason for why, but it's also helped us not get a freeze in our area. So here's the Arctic oscillation this year. Positive phase, kind of went negative there for a little while. Interesting timing, isn't it? What happened after that negative phase? We got kind of cool. We got kind of wet. We got kind of changed a little bit. But then it's come back a little bit to the positive right at the end of the rainy stretch. And maybe that's a trend. Based on this forecast here, it's trying to show we're going back positive, which means we might be switching patterns again. We'll see. Last year, negative. It was positive a little bit in summer, early fall, and then it just went solidly negative. And we think that when that long, persistent negative pattern led to the deeper snowpack and the colder weather in the east and allowed that Arctic high pressure to sneak down here just one time in February and give us the big ice storm that we saw February 3rd and 4th, 2011. Now here's one that's going to be a teaser for the climate change part, which will be the second half. One thing we've been noticing, which is kind of bizarre, is the increase in this oscillation pattern. Rather than just kind of a nice mellow oscillation, the last 30 years it's gone like that. And crazy oscillation patterns kind of mean crazier weather. So we have a year where we have this major event in Prague. We had a year last year, we had major snow in the Northeast, record snow in New York. We had a big ice storm down here in Texas. We had a pretty super drought in Texas. And this year we've had no snowpack, in fact, in some cases near record low snow in some parts of the U.S., where other parts of the world have been slammed in the northern hemisphere. We had big floods in Australia last year. Is this a trend? Is this related? We're not sure just yet. But it's something to keep an eye on, this craziness of the oscillation going to higher levels and lower levels as the oscillation gets more strung out. May be onto something related to climate change. Again, we're not sure just yet, but we're concerned. So it's something to think about as we move forward. Going back to the snowpack, here's your differences. This is this year in the yellow. You can see the white colored areas mean, yeah, there's some snow. Just a little bit of snow. That doesn't take long to melt. So within a day or two, that'll be gone. Then it comes back. So this is back in January when there's less sun angle. Right now, there hasn't been much snow there at all across the northern plains. They're dried out completely. Last year, different story. Look at all this dark blue and purple. That dark blue and purple is 50 to 150 centimeters. If you do the math, you're looking at 10 to 20 inches of snowpack or more on the ground. And that takes a lot to melt when it's been cold for so long, based on the Arctic oscillation being negative and continuing to produce cold air, which the snowpack feeds. Just like the dry ground feeds heat, the snowpack helps to feed cold, especially December, January, February. So positive feedback loops going on, and here maybe a negative feedback loop, or a positive feedback loop of dry ground, keeping it warmer, not allowing snow to stick around very long, and now we're into February. So this map kind of shows you the trend we think for February through April. You might want to nudge that up to March through May. February didn't quite work out that way. We'll explain why. But again, overall, we're talking about a 3-month trend. So we had a fairly good February so far, but you know what? When all is said and done, despite the fact that our rain will end up being, about 125 to 250% of normal, which is really good, the average temperature this month, you look at the forecast the next few days coming down the pike, 84, 85, 86 during the day. Nighttime temperatures in the 60s, near 70. Your average for the month is still going to be 3 to 4 degrees above what it should be and rank in the top 20 or 30, which means we're on track for this hotter or above average pattern. And that dry front we just saw the other day, get ready, more are probably coming. So we had a drought break, but I think we're heading back into that warm, dry type pattern that we saw last spring may be repeating itself as we get into March and April. So this map may not be too far off. Limited thunderstorms and showers on fronts, but yes, we've gotten them. It's not saying we won't get some showers and storms. We will get some, but as the spring wears on, maybe not as much through April before we get into some favorable patterns to get some rain in May, but not much. And sure enough, we had a February reprieve, and there we are. Good rain to the east of us, good rain over us too, actually just west of here, 2 to 3 inches in just a week. And February's average rainfall is about 1.25 to 1.5 inches in Central and Eastern Valley. We've doubled and almost tripled that in some areas for the whole month in just 15, 18 days. So we're good. We're good to go. You're going to see a beautiful spring into early March, and then we'll see what happens after that. Why did it happen? Well, the first thing people are saying is, oh my gosh, El Niño came back. El Niño came back. No, El Niño didn't come back. We had a reprieve. We had a pattern that changed a bit. Now here's the top map. Now here's what's interesting about this map. I'm going to kind of point to it. Where's the subtropical jet coming out of here? Do you see one? Do you see this? This is the flow of the atmosphere generally west to east in here, right? Do you see something coming out of here or not? Is there a yes or is there a no? Is that a don't know? What's coming out of here? Is there anything coming from the west? This is from the north here, going to the north, then west, then flowing back to the, moving west to east, okay? So if the flow is this direction overall, when it dives like this, it's going from north to south. When it comes up like that, it's going from south to north. When it comes this way, it's going from west to east, okay? Is that kind of clear?
It's bringing the moisture?
Well, is there a jet down here? Is there west winds? No. Exactly, no. And El Niño would actually say yes. If you go back and look at 2009, 2010 winter, you will find that there's a Hawaiian or Pineapple Express of moisture that's coming in almost through the whole winter. You can see it on satellite too. And that's deep moisture that the atmosphere needs to seed from the low levels on up to feed the rain. If you don't have it, you're not going to get it from that, so you're going to draw it from somewhere else. So in this unusual case, we actually had low pressure come from the Gulf of Alaska, dive all the way down into central Mexico, and to the right of that we had wind flow from the south. And where did that come from? The tropics, but not the tropics of the Pacific as much as the tropics of the Gulf and the Bay of Campeche. Tropical is tropical though, we'll take it, and we got it, and we got the rain this month from it. But it was not from an El Niño pattern. This is not an El Niño pattern. It came from here, it dove in, and it came up. And we think that slight negative phase of the Arctic Oscillation may have had something to do with it, the transition from a strong positive to a neutral to slightly negative. We saw this in December. May have had something to do with it. We're not sure exactly why. But we got a break in the drought for a week. The key word is for a week. So here's where we still are. Despite the fact that we had a break, we still have extreme to severe drought, severe to extreme drought, which is bad, across the entire valley. Despite the fact that we got good rain, despite the fact that we're greening up the soils on top, the deeper soil moisture is not there. And once we dry out the topsoils again, we're going to turn this red to a maroon again. And maroon is where we were for all the fall into early to midwinter, and we were also there during parts of the summer, and we think we're headed back at least for the balance of the spring, as we know spring to be March, April, May. So we'll see how it plays out, but it's something to keep an eye on. We have not improved enough to say we're out of this by any stretch. So it's looking good out there. It's pretty, but it's not going to last, we think. So don't get used to the beautiful weather. So expected weather, well, February worked out pretty good, but there's March, kind of worsening again. Going back into that drought phase. It'll be warm, it'll be humid at times, but it'll also be dry when some of these fronts go by. And it drops temperatures from, say, 90 or 88 down to, say, 78, still around or just above average. Beautiful day, but windy and drying the soil out near the top quickly. So even though we had some great relief now, we could turn that around in just 30 days. By April, we think it'll get worse. Warm to hot, little to no rain, plenty of wind. That was a bad month last year to really set up our drought. We're thinking it's going to happen again in April. And May, see April only hotter. But sometimes in May, you get a few fronts that can get more active because now the atmosphere is more stoked for severe weather, meaning it's warmer and more humid at the ground. It's still kind of cool upstairs, 25,000 feet. And that difference allows the atmosphere to be what we call unstable and turn into good thunderstorms. We saw that last May for about 5-10 days. We'll probably see it again this May. Maybe it'll be more than 10 days, but I doubt it. Or should I say, I drought it. As far as June goes, we'll have to see how things play out. A little too early to call June. Remember, El Niño, La Niña going to neutral. We're not sure what the oscillation will do then. The Arctic Oscillation is really hard to predict more than 2 weeks out. Darn it. We wish we could do more with it because I think it would help us predict patterns for 2 to 4 week periods within a whole season, which can really help people plan for what the year would be. So will it look like this again by June? Don't know. It very well might. I think we've had a little more growth, so maybe the corn stalks and the grasses will be higher, but they might be just as dry. So we'll have to see how it plays out. Now let's move around to the climate change side, which is part of the reason I'm here. Give you some overview on this. This won't be very long, but we'll have some time for questions, I think, 10, 15 minutes at the end. So real quick, the IPCC, you've all heard of that, Intergovernmental Panel on Climate Change. All this slide is showing that there's been a lot of research, a lot of study, and a lot of conclusions have been done in the last 20 years. There's a lot of things out there that have really gotten firmed up, and that's the key. Back in 1990, things were getting more firm, but by 2010, they're pretty darn firm. Main reason for that? Anybody have an idea why we got firmed up data now versus 1990 or 1980? Anyone want to hazard a guess?
Because we keep on seeing more catastrophes going on?
No. Other reasons for that. Climate change may be part of it, but I think very small. What do we all use today that we didn't use the way we ever thought? Think about this. Computer power. Think about what this does, and it took a whole room of vacuum tubes to do what this puppy does back in 1960. Okay, so we couldn't model climate very well. And you'll hear the skeptics, the people that don't understand the climate science say, well, you said it was going to be an ice age in the 70s, and it was a cooling period. Well, it was a cooling period. But the models didn't. Think about what computers were back in 1974. Think about supercomputers that have to calculate physics and math. They couldn't do squat compared to what we do today. And the government put a lot of research into not only computing technology, but people power to make this happen. So my feeling is the last 20 years especially, but going back 40 years, computer power, brain power have made the climate science much more robust than it was back in the 70s when there was still some question, and logically so. And here's the proof. This is what I call this is also a subtitle of the talk, man. It's the carbon, stupid. I mean, there really is no other answer. If you want to simplify this to your friends who don't understand, just show them this chart. Show them that it's the carbon. This is actually temperature and carbon, increasing rise with increasing carbon counts. And by the way, these aren't carbon counts by a sooty factory or in front of a bunch of buses or trucks. This is at Mauna Loa Observatory, one of the most pristine environments in the world in Hawaii. So these numbers are no lie, and you can see the concentration since the Industrial Revolution is exponentially increasing. Those of you who study geometry, trigonometry, calculus know what exponents are. Exponential, not linear. Big difference. Linear happens in the climate cycle. Linear's been happening for hundreds of thousands of years. That ain't linear. That's human right there. Those numbers, 392 heading off the charts, it's human. So humans are playing an impact in the carbon cycle. So climate change is a hot button topic. By the way, there's no belief in climate change or belief in no climate change. It is science. There's no belief, okay? It's not a religious thing. It's a science thing. It's what we've been studying for hundreds of thousands of years. The Earth's surface temperature has risen by about 1 degree Fahrenheit, and it's accelerated in the last 30 years. Acceleration, exponential. That scares me. The rise doesn't scare me. The rise is part of a cycle. The accelerated rise, that's a problem. We got to fix the problem. And again, you can see the evidence that human activities are causing it. Again, it's the carbon, stupid. Exponential rise. The only way you get exponential is a bunch of volcanoes blow, or we are adding stuff to it through all the burning of fossil fuels. Kind of makes sense. Think of what's happened since 1950 in China and India. Not only America. Think of what's happened in other countries in the Western Europe zone. Think of what's happening in the Middle East now in terms of the growth there. In contrast with extreme events, climate change is a long-term shift. It is not based on a weather event. So the person here is mentioning catastrophic weather events. Okay. There's a maybe there. Maybe it increases. We saw the Arctic Oscillation doing this, right? Waka, 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 shark going up like that. That could cause weather events meteorologically to have some increasing value to them. But anybody have a better idea as to why we're seeing more, quote, catastrophes, unquote? Real simple answer. Just think about it a minute. Is it related to the weather alone? Like I said, a little bit. A lot more something else. What's that something else? Heat. No. People. What about people?
They're living in places that are getting hit, whereas before they were getting hit, nobody was there to notice it.
Right. And keep on going, because one is living in places. What's also happened to people over the last 300 years? How's that increase been? Has that increase been linear? Exponential, right? 3 billion to nearly 9 billion by 2050. 3 billion just a couple hundred years ago. Uh-oh. More people means more resources being used. What else do people do, especially in fairly wealthy countries like ours?
Burn fossil fuels.
Well, yeah, but what else do they do just day to day, day in, day out, year in, year out?
Eat.
What else? We eat.
Waste.
Waste by what? We buy stuff, don't we? We buy lots of stuff. How many antiques are on the market these days except as antiques? Are we building furniture to last 100 years? No. Some people might be, but in the old days, they had furniture that lasts 100 years. Now you go to Rooms to Go or IKEA, whatever, you buy it, use it for 10, maybe 15 years if you're lucky, donate it, maybe hand me down, then it trashes, then it's done. Point about stuff is, not that it's trash, because some of it is, but not all of it is, but that we own more stuff. We're a consumer-driven society. More stuff means more insured damage. More people in harm's way with more stuff in harm's way means billion-dollar disasters. Okay, so yeah, climate change may have something to do with it. I think it's all the stuff we just talked about has something to do with it too. So we have to deal with that as well. But the climate change alone does reflect significant shifts in the atmosphere-ocean system, going back to the science, back to the numbers. And these do impact regional weather. This is back to the meteorology. Are the pressures lower? Are the temperatures higher? Is the actual rainfall higher? The drought that we just had in Texas, those are raw numbers, back 150 years that we broke all those records. That's not comparing an average to a 30-year average or a 50-year average. That's saying that the actual average for the year of 2011 was the highest temperature on record going back 150 years. Does it mean there wasn't another year somewhere in history higher? No, it doesn't. But in terms of our record keeping in 150 years, it does mean it's number one as far as we know. And that's a pretty long term. So there is something there meteorologically and climatologically that makes sense. This chart just shows I'll go back to it, the idea that global warming, if you want to call it global warming, exists. We're actually in global warming right now. No matter what you subscribe to, scientifically or not, we're warming right now. That's where we are in our latest system. Okay, we were there 150,000 years ago, 250,000 years ago, 350,000 years ago. Even within hundreds of years in cycles, we had these little ice ages, we had warm periods. Heck, at one point during a warm spell, the state of Washington was tropical. And England was tropical as well, with palm trees and what have you. So it doesn't mean it won't happen again. It probably will happen again because we have these cycles. These are the naturally occurring cycles.
That's in millions of years, right?
That's in hundreds of thousands of years, I believe. It's still a lot of years. And it can even go back, I think, more than 1 million years and track this. So the point is these cycles do exist. They may be related to how close, how far the Earth gets to the sun during its revolving around the sun over the course of centuries, over the course of Pleistocene and cycles of hundreds of thousands of years. We do change where we orbit in the sun. Even the tilt of the axis changes a little bit in time. It's not a perfect circle, scribed, or ellipse. So those things change and the climate cycle changes. This is not new. It's new because we've been studying it recently and finding this stuff out, but it does happen. And we're in a warming cycle. So anyone who doesn't believe there's global warming is false. There is global warming naturally occurring right now. What we're concerned about is how much we're adding to it. So there's the greenhouse effect. How many people have heard about the greenhouse effect? It may be hard to read this slide in the background, but the point being is that the heat-absorbing qualities of gases such as CO2, ammonia, methane, sulfur dioxide, nitric oxide, nitrous gases, what have you, are necessary to keep us alive. If we didn't have this, we wouldn't be here. We'd be Mars, we'd be Mercury, we'd be in trouble. So without this, you can see how cold it would be. We would average about 0 degrees Fahrenheit, which means, about 150 degrees Fahrenheit during the day, each day, and about 150 degrees below 0 Fahrenheit each night. Now, it's not a very good living environment for us, air conditioning, heating, or not. So we're a nice, cozy 57 worldwide because of the nature of the oceans, of the ground, of the land, and of the atmospheric gases that are just magic. And again, divinity may be a part of what makes Earth so great. But again, we're not concerned with the greenhouse effect. We need the greenhouse effect. What we're concerned with is the enhancement of it by adding all this stuff to the atmosphere. I'm going to take a quick break and grab a lozenge, if I can find it.
We only have about 7 more minutes.
7 more minutes is good. I think I've got enough time to zip through what's left. So let me...
There may be another class coming in, I'm not sure.
We can add a few minutes, hopefully, for questions.
The class starts at 1:10.
Oh, perfect. We'll be done. Okay, so again, the role of carbon, you can see the trend, exponential and exponential here. Even on a shorter time span, 2007 to 2012, we're just going up exponentially even there. That's a problem. That's a short-term rise. It's too rapid, and again, it's adding more than the natural cycle would allow. And again, this is the chart that I call the Al Gore chart. Whether you subscribe to Gore, like Gore, hate Gore, doesn't matter. This is the reality of the data. The magic red line is where the cycle should be. About 280 parts per million worldwide carbon count. Good deal. We should be there. We've been there before. We've been above it a little bit. No problem. Where are we now? Way off the chart. And if you've watched Inconvenient Truth, you see that one part where he's on the lift, and he gets lifted each time to these high levels, and then he goes up and up and up and up, and he's practically to the ceiling, saying that's where our carbon count is now. And that, my friends, is a problem, because that's all human right there. It really is. There's some of it, you can maybe add 2 to 4 parts per billion above the 280 or so, 2 volcanoes, 2 other natural causes, but you can't add 100 that way. No way, no how. So increasing about half the rate of fossil fuel emissions, that's a bad sign. It means that it's a slow increase, and we're blowing out the fossil fuel emissions, especially in the developing world right now. But here's the scary part. 40% of man-made CO2, they stay there, up there. They stay up there, and they stay up there, and they stay up there for a long, long time. By the way, going back a slide or two, anybody know why there's a rise and fall during each calendar year of carbon count in the Northern Hemisphere? What's going on there to make it rise and fall? The seasons, yes. And what about the seasons? What happens in the seasons? Yeah, plants grow, they actually take in some carbon. So you see the counts fall each summer to some degree. But even the falling is still rising. Notice you draw a line here, you got an exponential line with the falling carbon. So despite the fact that there's seasonal adjustment with trees and plants and water absorbing, it's not enough. And that's why another skeptic will say, well, the trees and the water are handling it. No, they're not. Because we're rising this lower edge, this lower bar here. They're not absorbing enough. Of course, the higher numbers here in the wintertime, trees lose their leaves, no absorption from the trees and grasses and plants. Water still takes care of some, the ocean takes care of some, but not enough to counter. And you see the natural rise that happens. So if you ever knew why that chart was oscillating there, that's why. So deforestation has led to some problems as well. Got a few slides left. We'll have a couple minutes for questions. Not only has carbon dioxide gone up, but other things too. Nitrous oxide, we talked about nitrogen. We have nitrogen. We need nitrogen in the atmosphere. It's important. But unfortunately, it's exponentially rising since the Industrial Revolution. Methane has gone up as well. Methane, that's an interesting one. What do you think causes methane? Some of that's industrial, but what else is going on with methane? Cow poop and other poops, I think, out there too. It's not a matter that we haven't had cattle. We have, but we have many more cattle now to feed many more people. And we're using a lot of land and we're creating a lot more methane because of land use. So that's a human natural kind of combination there where we're using nature to feed our species, but we're creating more methane that way too. And I believe that's part of the exponential curve here. So while methane is naturally produced by cattle, we're creating a lot more of it because of a lot more feeding that we're doing for a lot more people that need a lot more food. And then, of course, there's the sulfates that at least we've done some reduction to, reducing acid rain. Acid was basically sulfuric acid. We've reduced some of that, but there's still a lot of sulfuric acid out there, so it's a problem. Other signals, here's the glacial signal. Again, it's not that we're losing sea ice, it's the acceleration of the sea ice loss. It's not that the glaciers are retreating, it's that they're retreating very fast, rather than the slow retreat that they should be doing in this overall warming cycle. And the mean sea level is rising also at an exponential rate slowly, but it's still exponential than where it should be in the current cycle. They've backdated some model simulations to see how it would be if you went natural versus adding the human forcing, and you can see clearly that when you go natural and you add the human forcing, it goes back into that hockey stick chart. And there's people out there that say the hockey stick chart is bunk. Well, some of it is in terms of some temperature numbers, but the carbon number is not bunk. The carbon number is real, and it has been for the last 150 years. And again, more of that quick exponential range. This is the natural cycle. This is what's considered constant composition, no change from now on out. That would be wonderful, but that's not what the models say. Even the best model shows, with human interaction to make things better, shows a pretty good rise before a level off. But these other ones, especially this red one, if we do nothing, the red one is kind of where we're going. And these are temperature changes that could be as much as 5 degrees or 4 degrees centigrade. 4 degrees centigrade is about 11, 12 degrees Fahrenheit. And although it doesn't sound like it on a day-to-day level, boy, worldwide, that's huge. That is going to cause some kind of an impact. I don't think we want to stick around to find out what that impact will be. Maybe it'll be this. All North America gets really warm. We get more and more hot days and warm nights. We're seeing that now. We're not seeing that degree of rise, but maybe it becomes a normal thing to have 104 degrees days in McAllen, and the heat days in McAllen become 113. Maybe that's what's coming down the pike by 2090, 2100. Let's hope not, but maybe it is. And cold days and cold nights are likely to become less frequent or much less frequent. They already are less frequent now than they were just 30, 40, 50 years ago. Doesn't mean we're not having cold waves. We are. The world is still getting it. But the numbers of cold waves, the duration of cold waves, the persistency of cold waves is not what it used to be. Projections, again, here's some more percentage change values. Precipitation would become less frequent in some areas, but more intense in others. So while we don't get it as often, when we do get it, oh boy, do we get it. And we saw that in 2009, 2010. We had a record year in some places of rain, followed by a record drought. And that may be more the norm in 80, 90 years than the exception. And the southwest U.S. droughts will continue to worsen from less southern Rocky snow and snowmelt. Don't buy land in Phoenix right now. Don't buy land in Tucson. You know, you could. But if you look at the long-term 100 years down the road, I'm not sure how Phoenix and Tucson are going to exist. If there's no water flowing through the Colorado River out there, good luck feeding 3 million people water. You can desal all you want, but you can't desal for that many people and there's no liquid. And we're made of 70% plus water, us human beings, and we can't survive without it. So that could be a real problem down there. And it could be a problem for the valley. As we've seen in these drought situations, the reservoirs are where our water comes from. We did great in 2010. We held water in there 100%. All the way through last spring, we were able to buy ourselves a year. That year is bought. Now we're down to 70% at Amistad, 40% at Falcone. They have to decide how much for irrigation, so we have some beef cattle and crops for dry land to get some water into them, how much for human consumption. There's going to be a balancing act coming down the pike. These rains we've gotten now, oh, they were nice down the valley, but a lot of our rain needs to flow through Mexico. They didn't get that kind of rain that we need. We need tropical rains to do it. Maybe we get some next year, but this summer. Big unknowns. Exact impacts, very difficult. How much and how fast the warming will occur, still unclear. You saw that red line, but you saw some blue lines there too. It may not be quite as much, but it's still warming. And there's still large uncertainties in forecasting of specific locations. That's what we're trying to get our arms around in the next decade or two. And there's the IPCC report on what that means, about how complex this system is and these non-linear responses that can change your outcomes from season to season. You can still get record cold in Prague and a lot of snow in Prague, in Hungary, and in Czech Republic in years where we have climate change. It doesn't mean we're not going to get cold here again. We had an ice storm last year. So there's still some weather events that are going to happen that are going to make you scratch your head and think, well, really? But the overall trend is what we're looking at here. The decadal, multi-decadal, century, centennial, etc. trends, and millennial. So finally, weather's not climate to review. Last year's heat and drought are not examples of global warming. So people are going to say, oh, real dry winter, record warmth across the U.S., it's got to be true. No, it doesn't mean that. The trend is your friend, not the single season. So 2010's rainfall wasn't either. Cool, wet, snowy winters won't end because the climate is warming. In fact, we saw the last couple winters before this one a lot of snow and somewhat cooler in places where it snowed a lot. But again, the amount of snow was pretty impressive. Maybe the land you should be buying is in North Dakota or Montana, where the rainier seasons may become more frequent as Gulf moisture is able to penetrate that far into the plains, even into southern Canada. We'll see. Watch for trends. Is the winter snow going to be more common up there in Wisconsin and Minnesota and Montana and North Dakota? It's an interesting trend to see. More snow means more spring floods. Also means more soil moisture and more things can grow and more people can live. So not all bad news, I guess. But more frequent drought south of 30 degrees north latitude. Boy, a lot of people moved to the Sun Belt the last 20, 30 years. Will they be moving back north? Can't say right now, but it's a possibility we have to watch for. And one of the things I like to tell people is listen to those on the land. Don't listen to me as much. I live in air conditioning and heat just like you do. But people that live on the land, Eskimos, islanders in the Pacific, are seeing these trends firsthand. These are elders that have lived there for 70, 90, 100 years in some cases that are very attuned and in tune to the land. And because they're in tune to it, they understand these changes are happening. They're happening more frequently. They're accelerating, and they're scared. And maybe it's time that we try to do something. I think that time is almost past us. I think what we need to do now as a community of nations is mitigate against the disaster to come, because there seems to be no political will to slow down the train that's exponentially rising in carbon. That's my bad news of the day. I thank you for having me. I hope you all caught a lot. We got a couple of minutes, I guess, for questions, and I appreciate the time. Last but not least, before I open for questions, I have handouts here. If anyone's interested in becoming a meteorologist, by the way, I'm a meteorologist, not a climatologist. I just try to do this as my night job. But I have a lot of handouts here about how to become a meteorologist. There's a hurricane guide, which is award-winning, by the way, that we worked with several different partners on. That's last year's version. It's still good for any year that you need. I got some Facebook cards. You can join our website and our Facebook page, and some cloud charts if you want to learn about the clouds a little bit more. So on that note, I'll open it for questions. When you're done, come by here and take some of the stuff. And again, thank you very much. Are there any questions? Yes, sir.
Yes. Does the speed of the tropical jet stream that travels right through the middle that causes the dryness in South Texas, is it going to speed up because of the heat?
Okay, you mix it up. The tropical jet stream is not caused by the dryness. It's caused by the thunderstorm complexes in the eastern Pacific Ocean. That creates wind shear, which is a form of a jet stream high in the atmosphere. And that moves that moisture from, say, Hawaii eastbound, or say, near the equator, east to northeastbound and gets to us. There are elements that help to speed it up in the atmosphere that help to create the individual cyclones or storm systems, not hurricanes, but winter storm systems that will give us the rain. We had 3 of them in 2009, 2010. They were actually like nor'easters in the mid-Atlantic coast that were on the Texas Gulf Coast. Gale force winds, 4 inches of rain, cold temperatures on land, but really interesting looking, and that was because the jet stream helped create that, because upstairs what happens helps create what we see on the ground downstairs in the atmosphere.
So they create more rain rather than dryness?
When the jet is not there and the tropical moisture is not there in depth for a long period of time, it's dry. We have to get it from somewhere else like we did this month. We got it from somewhere else, but as you can see, it's not going to last. It's going away. So that's why we're saying March and April, back to what we had in January, back to what we had in November.